everyone, welcome to our video presentation on multi-threading GUI applications, and we are a group 5 and I'm Mariel Suarez.
I am Jasmine M. Bakayan.
Good morning everyone, I am April May Garcia.
So let's get started. The content, the problem, why your app praises the liveness failure, the solution, threads to the rescue, the new problem, the dangers of shared data, safety failures, the golden rule, protecting the UI, framework-specific implementations, marshalling, best practices, and modern tools. What is multi-threading in GUI applications? Multi-threading in GUI applications is a programming technique where an application is divided into multiple, independent threads of execution that run concurrently. This is primarily done to prevent the graphical user interface GUI from freezing or becoming unresponsive when performing long-running or resource-intensive tasks. Example, let's say you're using a mobile app to upload a large video. With multi-threading, the app can run the upload process on a background thread, keep the UI thread free to handle user interactions, and render the upload progress. This way, the app stays responsive. You can still interact with it, scroll, or cancel the upload if needed. The GUI doesn't freeze, providing a smoother user experience. Then the next slides is the problem why your app freezes, the liveness failure. Key point 1, the single-threaded nature of GUIs. All frameworks, Qt, Java, FX, WPF, or etc. use a single special thread for the user interface. Then sa key point, the UI thread's job responsible for all rendering, drawing, and handling user input event, clicks, key, and presses. Then key point is the blockage any long-running task, network, I/O, file access, complex math on the UI thread blocks it, making the app unresponsive. Visual or analogy, a single cashier tried to serve customers and stock the entire store. Example, imagine you're using a mobile app to upload a large video. If the app is single-threaded, the UI threaded will handle both rendering the upload progress and the actual upload process. If the upload takes a while, the UI thread gets blocked, making the app unresponsive. You can't interact with it, can't scroll, or even close the app easily. That's a liveness failure, causing the app to freeze.
The solution threads to the rescue. UI thread, main thread, worker thread, background thread, result, benefit, responsiveness, smooth user interaction. Multi-threading, executing multiple tasks concurrently to improve performance. So, when an app performs heavy tasks like downloading or saving files on the main thread, it freezes. To fix this, multi-threading uses a worker thread to do the heavy work in the background, while the UI thread is still responsive. Example, in Android, when downloading a large image using a background thread, you can still click buttons and move around the app. It doesn't freeze. It's like a restaurant. The cashier UI thread handles customer while the cook worker thread prefers board. The next is the new problem, the danger of shared data safety failures. Problem 1, race condition. When multiple threads try to read, write the shared mutable state simultaneously, the result is unpredictable. Problem 2, deadlocks. A scenario where two or more threads are stuck in infinite wait, each waiting for a resource held by the other. Analogy to cooks trying to update the same shopping list without coordinating. So, when threads share the same data, errors can happen. If two threads both increase the same score variable, one's update might be lost. This is the example of race condition. Example of the deadlock is thread A lacks file 1 and needs file 2, while the thread B lacks file 2 and needs file 1. Both get stuck. An analogy example to cooks writing in the same list at the same time will mess up it block each other. Then, the golden rule protecting the UI. Reason, GUI components are not thread safe. Direct access break the UI framework's internal consistency. Never direct access or modify a GUI component from a worker thread. The mechanism. UI thread marshalling or posting worker threads must package the result and send it to the UI threads to safely apply the update. Key component, invoke, post, signal, using framework provided methods to execute code on the UI thread. So, GUI components are not thread safe. You should never change the UI directly from a worker thread. Use the UI thread to update the screen safely. Example, in Java Swing, use saving utilities that invoke later. In Android, use run on by thread or handler.post.
Garcia. My topic is all about framework-specific implementations, marshalling. First is Swing Java FX. What is Swing Java.fx? The term Swing and JavaFX refers to two different Java GUI graphical user interface toolkits. They are both used to build desktop applications, but they are separate libraries with different architectures and capabilities. Swing Java.swing introduced in Java 1.2 late 1990s, part of Java Standard Edition type legacy GUI toolkits. The characteristic of Swing Java is uses the pluggable look and feel based on the older abstract window toolkit or AWT provides components like GFrame, GButton, JLabel, and etc. Is still widely used in many enterprise applications. Fully written in Java, 3D model uses the event dispatch thread or ADT for GUI updates. Then the JavaFX introduced around in Java 8 2014, replacing Swing as the modern GUI toolkits. Part of now separate from GTK from Java 11 onwards, type modern GUI toolkits. The characteristic of JavaFX is support modern UI design including 2D and 3D graphics, animations, and CSS styling uses FXML or XML-based UI markup language. For defining ULS, declaratively components include stage, scenes, button, label, and etc. Then the second is C#. What is C#? C# is a modern object-oriented programming language developed by Microsoft. It runs on the .NET platform and it's used for building wide variety of applications including web applications, desktop applications, mobile applications, and games, APIs and backend services, and cloud applications. The key features of C# is the object-oriented, uses classes, inheritance, and etc. Type safe, reduce bugs due to type errors, modern syntax inspired by C++ or Java, automatic memory management via garbage collections, strong support in Visual Studio and other IDEs, interoperability with other .NET language like F#, BV.NET. Then I have a simple example of C# code. This code, it can print hello world to the console, the classic beginner program. And the third one is Python. The word Python can refer to different things depending on the context, but in the world of technology it commonly means Python is a high-level interpreted programming language known for its simplicity, readability, and versatility. The key characteristic of Python is easy to read, high-level language, interpreted language, dynamically typed, multi-paradigm, large standard library, huge ecosystem. Then, what is Python used for? It is used for web development, data science and machine learning, scripting and automations, game development, then desktop GUI applications, cybersecurity, hacking tools, IoT, and robotics. So I have a simple Python code. This program prints hello world. Then we have 3 best practices and modern tools. First is use specialized helpers. This means use built-in or well-designed helper classes methods to handle concurrency or threading instead of writing everything yourself. Example in C#, task that runs work on the background thread parallel for each, parallel processing, blocking collections, thread safe collection for producer-consumer scenarios, Simorpholisms Mutix monitor for controlling access to resource, asynchronous await or simplifies asynchronous programming. The second is limited shared mutable state. This means avoid multiple threads accessing and changing the same variable or object at the same time, unless you have synchronizations in place. The problem is, for example, the problem is when two threads modify the same data without coordination, it causes race conditions, data corruptions, or bugs that are hard to reproduce. So the best practice for this problem is favor immutable object or object that can be changed after they created, and use local variables inside threads. They're naturally thread safe. If you must share states, protecting it using lock keyword, concurrent dictionary, concurrent queue, and etc. Interlock class or atomic operations. So the third one is use threadfuls. So use threadfuls is instead of creating new threads every time, which is expensive, use the .NET threadful which reuses threads efficiently. In C#, use task or task.run. It automatically uses the thread pool. Avoid manually creating threads with new thread unless absolutely necessary. Why? Thread pools improves performance and scalability, avoids overhead of thread creation and distractions. So that's all. Thank you.